Hello everyone, let us continue our discussion on uniform circular motion. If athlete moves with a velocity of constant magnitude along a circular path, only change in his velocity is due to the change in the direction of the motion. We have considered the circular path, and on the circular path, when the athlete was running with a constant speed, then in that case, the change in velocity of that athlete is not because of change in velocity. It was because of change in directions, right? So what we considered that as for different shaped tracks, from rectangular shaped track, hexagonal shaped track, regular octagon shaped tracks, as the number of sides of the tracks are increasing, that many turns athlete needs to take. So number of turns in that case will be equal to number of sides of a track. And now if the number of sides of a tracks are infinite, then obvious the athlete has to take infinite number of turns, right? So if he is taking infinite number of turns, means like this, here this each red arrow indicates particular position. When the athlete, when he is at this position, this is the direction of motion at that time. When he is at this position, this is the direction of motion at this time. This is the direction of motion at this time or this position. This is the direction of motion at this position. This is the direction of motion at this position. But the thing is, as we have considered an infinite number of turns or infinite number of directions, here just for understanding or just to show in picture, we have shown one, two, three, four, five. Five directions only we have shown at different positions. But actually, if the number of turns are infinite or infinite directions are there, he will take that many infinite number of turns, right? So such here, what red arrows we have shown, they should be in infinite numbers. Just to show in picture, we have shown five, right? So here, important thing is the change in velocity of that athlete because of change in direction of motion, not because of change in velocity. The thing is, the athlete has maintained his velocity constant on that circular track. So such kind of motion is called as uniform circular motion or accelerated motion. Now, while running on this track, we know, so this is a circle and the circumference of the circle is nothing but 2 pi into r. Now, as we said, to complete one round on this circular track, athlete, suppose he takes t times. So athlete takes t seconds to go once around the circular path of radius r. The radius of this circle is r, small r, and to complete one round about this circle, the athlete takes t seconds of a time. And I want to find out the what is the speed of athlete, right? We wish to know the speed of that athlete. How to calculate the speed? The basic formula we know, speed is equal to distance divided by time. Here, what is the distance? Distance is nothing but the circumference of this track or circumference of this circle, right? And time is, see, speed will be equal to circumference of a circle divided by time taken to complete one round. To complete one round, how much time that athlete has taken, and distance is nothing but the circumference of this circle. The circumference of a circle we know 2 pi r and time is t. So speed we can give as v is equal to 2 pi r divided by t, right? So when an object moves in a circular path with uniform speed, like this athlete is moving with a uniform speed or a constant speed on the circular track, then such motion is called as a uniform circular motion, right? But for uniform circular motion, important thing is the change in velocity is because of change in direction. It is not because of change in magnitude of velocity. It's just because of change in direction. Object moves in a uniform speed on a circular track or circular path. Three important words are there: object, circular path, and uniform speed. While traveling on a circular path, object has to move with or travel with a uniform speed. Then such motion we call it as uniform circular motion. Thank you.